Hi, good afternoon, everyone. My name is Soleil, this is Tyler.
Hi.
And we're going to talk to you about our experiences in the 2015-2016 election. And yeah, some of the challenges we faced and what we saw with our platform. So to get started, I should probably present the problem that we're trying to solve. Personal one-to-one interactions are probably the best way to engage your constituents. And this is something that we believe very strongly at Hustle. It's the reason that we decided to build the platform that we're going to tell you about today. So this is a rough estimate based on a budget from actually one of the folks that works at Hustle currently. But most campaigns spend between 35 to 50% of their budget having conversations either with volunteers, supporters, or directly with voters. Or directly with voters in the lead up to polling days. In target states, people can receive multiple ads, direct mail, and fundraising asks, sometimes on a single day. Cutting through this noise to encourage people to get out and vote and take action, whether that's as a volunteer to talk to voters or as a voter themselves, is vital to the health of any campaign. Sorry. Ooh. So traditionally, campaigns can have some trouble reaching people. And it can be very slow to do door-to-door canvassing. This can also be very expensive. You need to have lots of volunteers that are willing to go door-to-door, that feel outgoing, that can dedicate multiple hours to this outreach. On the other side, you've also got phone banks, which are a little bit easier, but as people move away from landlines to mobile, less and less people are picking up the phone. And the reason for that is they don't recognize the phone number, or can't get to the phone at that point in time when you're trying to reach them. So at this point, I usually like to ask the question to an audience, who in this room actually received a text message from a campaign or organization during the 2015-2016 election? Okay, awesome. Good, some of you did, great. So as you would have noticed, some of you probably were also, they tried to call you. So you wanted to hear from these campaigns, but you couldn't be reached because you were busy at the time of when the call was made, or you weren't at home when they tried to canvass. So what Hustle decided to do is we decided to build a platform that reaches you via text messaging. And our system creates individual personalized texts that are sent by a single organizer to a real person. So each text is manually placed. There's no blast nature to the tool. And the asynchronous nature of text means that you can get a text message and text someone back whenever you have the time to do so. You can ask questions and as a result get more involved in the organization as and when you choose. So we found some interesting stats that we put up on the board up here. It's up to 30 times as fast to text people as it is to do some phone banking. And we usually see a sort of 3x response rate compared to phone calls. In some cases, you can be 2 or 3 times more likely to actually volunteer if it's the first time that you're being texted as well. So here's a picture actually from a Bernie barnstorm in Oklahoma, where the question was asked, who came here because they received a text message? And what we saw as part of our work in the election was that lots and lots of people actually showed up to events when they received a text message. And this was more so than when they'd been tried to call or when people had tried to canvass. And we've seen similar responses to event turnout for multiple organizations. If you're interested in volunteering, I know some of you here have an hour to volunteer your time. We work with all types of organizations, including Planned Parenthood, Move On, Forward.us, Human Rights Campaign, and the Hispanic Federation. So if you're interested in volunteering with any of these organizations, please come and see us afterwards. I'll be happy to put you in touch. So how does Hustle work? Well, we created these workflows that enable a single texter to send out around 1,500 texts an hour. And we're working every day to try and make this as fast as possible. Each text is manually placed, which means that each text that is sent is kicking off a unique conversation with a supporter or a voter at any one time. During the election, as you'll hear from Tyler shortly, this means that we have to deal with these challenges at scale. So we want to encourage real organizations, and so we'll check in with you to make sure that you can actually get back to your replies, or if you want to send on more messages. So with that kind of background in mind, let's talk about the 2015-2016 election. For Hustle, over 5 million messages were sent on election day alone. This is something that we find very surprising, as you'll see why. but it's something that we're very proud of. We managed to support and stay standing to support this many messages going out in a single day. Here are some stats from our election sort of dashboard. You'll see on the board actually that it's kind of small, but Nevada, if I can show you, yeah, about 14% in Nevada. So in states like Nevada and Florida, we were one of the primary tools used by field organizers as well as nationwide operations. In Nevada, for example, it means that about 1 in 7 people received a text message from us. Many of those text messages were encouraging for them to get out and vote. SMS is also a more level playing field. The only thing you need to be involved in a texting campaign is a phone that can receive SMS, which means that you can be from any income bracket, you can be from any racial or gender class or any of those kinds of divisions in society. You can be from any of those brackets and still get a text message. That means that everyone can be involved. And that's what makes text such a sort of unique and excellent tool for campaigns to use. One particular experiment we saw with the New York Civic Engagement Table was just texting turnout for the New York primary. And they saw a 10.5 percentage point increase in the Hispanic voter turnout in the New York primary, which is phenomenal. It's like 300x what you would see from door to door. So some overall stats. This is just the month leading up to the election. Overall, we saw that we reached out to just around 5% of the eligible voting population, that's countrywide, about 10 million unique people. With this current response rate, and a lot of it was responses getting people to go out and vote, our response rate here is actually cutting out anyone that opted out or anyone that responded after the time window when the snapshot was taken. But that means that we held close to about 1 million conversations with voters across the country. Ensuring that our system stayed standing so that these conversations could continue was of the utmost importance. Nothing was more important and vital to us than making sure that this happened. And we worked very hard to do so. So actually, this is where I want to pass it over to Tyler to talk about how we actually did that on our back end.
Well, thank you, Soleil. All right, so Hustle's been around for about 2.5 years now. And we didn't go from 0 to sending 5.5 million messages in a single day overnight. This has been a gradual process. And at each stage of growth for our company, we've discovered a couple of different things about how we should build and how you should build a reliable platform for messaging. So today I'm going to share some of those with you. And if you find them interesting, come talk to me afterwards. So this is a chart of what our messaging volume looked like in 2015. It's actually, there's not much volume to speak of. We have some spikes where we send 10,000 messages a day, maybe some that even reach 30,000, but it's not too impressive. The interesting thing about this chart is, throughout 2015, we already saw that our company started to have and make a meaningful impact and change the way people were organizing and how people thought about getting people to events. But we saw, even at this low volume, we saw problems start to emerge. So, in 2015, we're looking at the volume graph I just showed you, and our memory usage graph looks like this. We were running on Heroku at the time. And so we've got a major problem, if any of you have ever looked at this graph before, because the memory usage keeps increasing, and then increases up until the point the app actually restarts, drops down like a stone, and then continues increasing again. And as we started to add more and more volume, the cycles at which this would happen, the period between which this would happen in got shorter and shorter and shorter. Eventually, our app was restarting every 10 minutes or so because we'd run out of memory. So this is not great. And it turns out we're not alone, and this is not unique to us. During October and December, a lot of popular libraries, this is just a sample of 2 that we had in our particular stack. We were using Parse, and Parse actually built their SDK so that they wouldn't clear the IDs that it had seen, so it was just always eat up more memory. And actually, the Node runtime itself had a memory leak. And this is, if you remember back at the end of 2015, this is a really interesting time for Node. ES6 was just sort of starting to be incorporated into into a lot of projects, and a lot of people were rewriting their code bases to take advantage of these features. So actually, rolling back to a previous runtime was not something that was an option. Everyone was addicted to using these features, and they actually couldn't. Or they couldn't very effectively in production, at least. So there's this long conversation about how to deal with this on the Node.js node repo. And Hunter Loftus he's the Node.js expert at Heroku. And so he chimes in at some point and says, look, the state of the art for when this pops up is to basically specify this flag, max old space size. And the thinking here was, hey, this JavaScript interpreter, V8, that's running, usually has run of your computer and can use as much memory as it can gobble up. But if you specify max old space size, it'll basically make the garbage collector more aggressive and say, hey, if I'm limited to this amount of space, maybe I should collect more frequently. In practice, though, what happens is, yeah, it might be a little bit more aggressive about running the GC. A couple of things might be collected earlier than they would have beforehand. But you will still run out of memory if you have a memory leak. And what happens when you get there is that your app will shut down hard. So Hustle was growing, and we needed a solution. And what we came up with was a thing we call regiment. And I wrote this in about a day. It's fairly simple, but it's an abuse of the Node.js cluster module, if any of you are familiar with it. And what it does, what the cluster module does on its own is it basically lets you spin up two types of processes, master and workers. So the master receives requests and then delegates them to the workers to work on, and this lets you parallelize and increase throughput on Node.js applications because they're essentially single-threaded. So this lets you run multiple processes to handle requests. What it doesn't do is help you when these workers happen to die or blow up for some reason. It doesn't help you restart them and keep them running, or gracefully shut them down before they're about to experience a problem. So the module that we built essentially says this. You specify the number of workers you want. In this example, we'll say, hey, we want 3 at all times. And we have some middleware that can detect when things are starting to go wrong. So on every request, we'll check and say, hey, how much resident memory are we using now? Is it close to the limit that we set? So if we had a gigabyte of memory on the instance we were running, we'd say, hey, when we get to 700, raise the red flag here and decide to die. So basically what this allows us to do is say, the worker can send a message to the master and says, hey, I'm not feeling good. And the master spins up a new worker to replace worker 2. Worker 4, when it comes online and is ready to receive requests, it can send a message back to the master that says, hey, I'm available and I'm ready to receive requests. Please tell worker 2 that I'm replacing them. And then worker 2 can gracefully go away, and you can maintain this consistent environment where you have 3 workers processing requests, but they can shut down gracefully without you losing a single request and without losing any traffic and dropping traffic. And this is extremely important given what Slay was saying about, people are having real conversations on the platform. It's actually unacceptable to drop a message or two, right? Just because we have an unhandled exception or we run out of memory. So this is a really cool way to deal with that, and a really nice way to basically try to contain things that you can't really control. Because our first lesson as part of building a scalable platform is essentially prepare to deal with issues in other people's code. Just think about it. Think about how many NPM modules or Go libraries you depend on when you're building something. There's thousands, even in small projects. Otherwise, your projects wouldn't be very interesting. You'd be building everything from scratch. And so, if you think about how much code that you depend on that you didn't write, and we went nuts pulling our hair out trying to find the problem and the leak in our own code, only to realize that the node runtime itself was leaky, right? So the first lesson is definitely prepare to deal in any way possible with issues in other people's code. So that's what we looked like in 2015 and the kind of issues we were running into. But this is what the first half of 2016 looked like. So you can see that there's an order of magnitude increase in the volume we're sending through our platform here. The average day, it's not unlikely to have 200,000 messages go through it. We have spikes on some very important, near some very important election time periods that go up to 700,000, 800,000, and then right up at the end there in June, start of June, that's the primary, the day before and the day of the primary that I think we sent like 1 million messages on both those days. So in order to message and communicate with that many people, we need to ingest a large amount of leads. And we need to determine whether they're eligible to receive text messages. And the way we do this is using Twilio's phone number lookups, which is great. We do this by basically saying, OK, when you upload a lead, we'll check to see if the phone number is a mobile, a landline, a VoIP. And if it's a mobile, great, we can text message it. If it's a landline, we obviously can't, unless there's some new sort of landlines I don't know about. And VoIP is kind of a mixed bag. We don't know. Some of them may be able to be SMS enabled, some of them might not be. But in general, we want to filter down this list and scrub the list so that it's only mobile numbers, so that if we're asking people to donate their time and spend their time sending messages, we're doing it the most effective way we can. So this works when you have lists of 1,000. And the way it works is, 1,000, 10,000, we select the CSV, you click import, and we start looking up the numbers and importing them into our system. The problem is, this takes a really long time when you're uploading lists with 100,000 leads in them. It takes so long that we built in our own version of Flappy Fist called Floppy Bird, that we call Floppy Fist. And we had you play it while we were uploading these leads. So is this Twilio's fault? Not really. We actually just didn't read the documentation close enough. So the documentation actually says you can make 100 concurrent GET requests to look up Twilio numbers and look up phone numbers. So a reasonable first pass at implementing this would be, and this is actually what we did, is say, hey, let's split the batches into 100 phone number chunks. Let's send requests all at once to look up those 100 phone numbers. And then, once we're done with that, we'll do the next batch. Seems pretty reasonable. The problem with this is, even if 99 out of 100 of those requests return in a reasonable amount of time, let's say 100 milliseconds, the internet is a crazy place. Anything can happen. And if even one request takes a little bit longer, maybe it takes 3 seconds, the whole next chunk is blocking, waiting for this 3-second request to finish. So a much more mature approach is to write the code in a way that allows you to keep 100 requests in flight while processing the entire chunk of numbers to look up. So that would look something like this. So even though some requests are completing, others are able to be sent off and kicked off. And so even though this one request is taking a long time, this red one, it's not blocking forward progress. This is much more effective. So an engineer on our team actually wrote some code to do this with promises that I think is particularly well done. So I'm gonna show you it. It's actually a fun little exercise if you ever want to do something like this. So we called it parallel limit. And there are other libraries that have something like this. Async is probably the most notable one, but it doesn't use promises. It just uses callback style, continuation passing. So I think other people have done this as well, but this one's pretty cool. So it basically is just a semaphore for promises. So the way it works is the function is called parallel limit. You pass in an array of tasks, which are just functions that return promises. And you tell the function, hey, I'd like to run some limit of these at a time. So let's say 100 concurrently. And the code's pretty easy to understand. You'd say, hey, if we've got no tasks to run, we're done here. Let's finish up. But if we do have tasks to run, let's create a promise that'll return the result. Let's make some bookkeeping variables. Let's define a run function, which I'll explain in a bit. And while we have more tasks to run, let's spin up to that limit. So let's start running 100 of them. And then we'll return the result promise. So what does this run function do? It basically pulls a task off the task list. And if there's something there, we run it and record the results. Either there's a positive result because the promise was resolved, or an error because it was rejected. And then always, no matter whether it was a failure or a success, we call the run function again. And so you'll notice that when we go back and you enter this function and there are no tasks remaining, what we do is decrement the running count. And once we reach 0, we return the results. So this is pretty nifty. really helped increase the speed of our lookups by quite a bit, and helped us, because when some of those requests would block, it would basically make it so that that was basically unnoticeable to the user. So this is great. Okay, so the lesson I wanted to impart upon everyone here at this second stage when we were in the first half of 2016 is that I often get scared, and it might seem scary to refactor some critical code that you wrote a while ago that can't break, because essentially Hustle actually charges by the lead in our system. So this code is very critical to us making money. No one essentially wants to touch it, and it essentially worked. But in having a year's more worth of experience and both working with Twilio and working with Node.js, we were able to write something that made it a lot more performant. So this is great. All right, so let's get to the point and why everyone's probably here, which is the second half of 2016. So we had an interesting challenge here. We actually had to scale the amount of volume we could support 100x in 6 weeks. So we did this with a team of 5 engineers. I was the only one doing ops. And contrary to most startups that are building up infrastructure, ours has to be very elastic. So not only do we have to build up to scale up to this 100x level, right, where most days we're sending 50,000 messages, and then 6 weeks later we have to send 5.5 million. We also the very next day have to spin down all of our infrastructure immediately because we're getting charged a boatload, and the volume has dropped off, increasingly, basically back down to 50K a day. So what are some lessons we learned doing this? Basically, we had a team, these 5 engineers that were pretty experienced. We have some alumni from Facebook, alumni from other places that have built huge distributed systems. So we knew the basics, and we knew sort of the ropes to get us half of the way here. And as we were staring up at this thing and saying, holy crap, a lot of people are going to be sending messages on election day. All of our clients are going to be blasting everyone with a lot of messages. How should we deal with this? And the general way you start is you say, okay, well, in the beginning you're developing and you got a web server and it proxies requests to a backend. And everyone starts out this way, and life is good, and this is how your development box works, and it's fine. Eventually you say, okay, well, I need to make sure this service is always available. I need to distribute the load across multiple nodes. And you go to this sort of architecture where you have some sort of load balancer, and it distributes requests amongst various instances of your backend. Okay. So clearly, you need to be able to scale your backend horizontally. You reach the phase at which you realize, okay, well, we don't just want to have more instances of backend, because backend isn't this one brick that you need more of. It's actually composed of a lot of different services, right? And in our case, there's an API. There's bulk exports, there's an assigner, there's CSV import, there's 10 different other ones that are composed in this big gray brick. And we don't actually just want more of all those things, we just want more of some. And so you have to build this service in a way such that you can have 100 instances of the API tier, 200 instances of the API tier, and still only 3 CSV import workers, because that's what you want, right? And you need that flexibility in order to be able to scale these components independently. So we've done this before. We get to this point and we say, okay, this is the kind of thing we need to build. We can add more API if we need more API. And the databases are also horizontally scalable, so we can add more database nodes if we need that. And life is good. We're a week away from the election, and this is what the architecture looks like, very crudely drawn here. But essentially, we have a couple of workers, and we have a ton of API tier, ton. And what we recognized is that all of a sudden our Redis instance starts falling over and says, hey, I have way too many connections. We're using up all the file descriptors. All right, rookie mistake. We go and look at the server where we're running Redis, and it's like, okay, did we set all the U limits? Did we, are we clearing the logs? Why is Redis having such a hard time handling all these connections? And we looked at it and we said, hey, the U limits are set actually really high. The number of file descriptors that this thing can open is an absurd amount. And it actually turns out that each instance of our API tier was running a Redis client. And the Redis client internally had its own connection pool of sockets that it would open and keep open up until, it was probably opening 10 per client almost, maybe even more. So each of these things was opening up, each of these instances of API was opening up, tens of connections. This is not what you want. So we did a quick hack. We wrote a service called the Hustle Job Runner. And basically, the Hustle Job Runner would take HTTP requests on behalf of the Redis that were messages that we wanted to send to and receive from Redis, and then communicate to Redis on your behalf. And so what this let us do is basically embed the Redis client in the job runner and have that maintain a connection pool, which is really helpful because it wouldn't have to open up a new socket and you'd have to pay that cost every time you wanted to make a request. But we did have everything else that was communicating it with the job runner use short-lived HTTP requests instead of long-running, these long-running open sockets that it would be kept open forever. So the last thing I wanted to impress upon everyone, that last stage, was basically just to say, hey, ensure infrastructure components are built to be scaled horizontally and independently, and ask questions such as, hey, how does this change if I have 10 of these? How does it change if I have 100? How does it change if I have 1,000? Because often the things you run into are not things you expect. And in this case, for us, it was absolutely that the Redis client was built at a different layer of abstraction than we needed, right? Most of the time, you just have one or two instances of this thing running, and they both connect, and it's fine. You actually do want a connection pool. It's great. But for us, I actually didn't know going into it that the Redis client was designed that way, and that's what we learned. And so it's never, whatever breaks at that scale is not always what you expect. So I'm going to hand it back to Soleil.
Okay, so I think we have a couple of minutes left. So we just wanted to kind of explain some of the challenges that we had trying to get up to the scale that we did on election day. And as Tyler mentioned, after election day, we went straight back down to about 50,000 messages a day. So the question that we were asking ourselves is, what comes next? And so that's kind of just a quick slide here of places that we're looking at in terms of where text messaging is powerful, where we think it will be useful. And there are different types of organizations that we've seen have great success with it. So we survived the election, but there are still non-profits and cause-focused organizations that use text messaging to communicate with their members. And so having this elastic backend allowed us to scale up and down depending on different events that are happening throughout the calendar year. Especially with our new president, there's a lot of opportunity and chances for us to get involved with legislative contact and raising money and fundraising. So these are two kind of goals that we've put in place where we want us to enable people to be able to call their legislators and enact real change. We've seen unions using it for members and workers' rights, strengthening the union's ties to their members, and giving workers another way to report workplace issues. And even in higher education institutions, we've been seeing them using it for enrollment, annual giving, in some cases up to a 40% increase on the actual donations that they get from young alumni. In terms of the new use cases, legislative contact we've already seen put into place for people calling their legislators to fight against the repeal of the ACA, immigrant rights, trade agreements, and internet accessibility. And we're sort of proud to support all of those use cases. We've also tried expanding internationally, so now working in Australia, which presents its own set of Twilio problems, so maybe that's another talk we can, or own set of Twilio relationship questions, I guess, we can talk about another time. But in Australia, there's a much noisier environment. They don't have as much regulation around text messaging, and even in that noisy environment, that one-to-one communication is still more effective than you may expect. We see most of our Australian partners will have at least a 30% response rate with the members, and this is with local unions we've been working with. So this is just a quick quote about us that was on TechCrunch. And yeah, our sort of main mission in life is to help motivate people to participate in action at scale. We think that there are all these different channels and mediums by which you can do that, but if we can help organizations build relationships at scale, then we've done a good job. So if you would like to get involved and then volunteer your hour of time, that I think everyone here at the conference is supposed to do, please come and find us afterwards, and we'll connect you with any organization we work with that you'd like to sort of donate time with. And yeah, that was Hustle, and that's how we scaled Scaled, organized at scale, I guess.